Are you tired of finding a way to control the brightness of your LEDs? So on this Friday, in EFY's Live DIY, we bring you the LED dimmer circuit using 555 timer. Hello, hi and welcome to a new DIY video from EFY. This is your host for today, and in this video, we'll be making a very simple DIY LED dimmer circuit using 555 timer IC. So the main component of this circuit is a 555 timer IC, which we'll be using in A stable mode. So the circuit is kept here, and first of all, I'll show you the initial demo of the circuit because there are a lot of connections. So let's see how it works. So this is my potentiometer, and I'll be using to control it to change the intensity of a light. So I'm rotating it, and as you can see, the intensity of the light is increasing, and as soon as I rotate it towards other side, the intensity keeps on changing and it keeps on decreasing. Actually, we can use the same circuit to control the speed of the motor as well. So I have the motor too, and I'll just first remove the LED strip. What I've done today is that I've used the blue wires for positive and green for ground or negative. So this is a positive rail where I'm inserting the blue wire. Hope you can see it clearly. And this is the negative, or since we are connecting in channel MOSFET. So now, as you can see, the speed of the motor is controlled by rotating the knob. I'm trying to slow down the motor. So we are using basically PWM. Actually, we can control the speed of the motor even by using a resistor, but that is not the efficient way, because in that case the efficiency goes down because a lot of energy is wasted in heat. So what we'll be doing is I'll just remove all the components and show you all the important components in the project, and we'll design it once again. This is our MOSFET, N-channel MOSFET, IRF Z44N. This is used for this is used as a switch. I'll just remove all the components first and show you the important components. These are just connecting wires. So I'll explain you the connection while we make the connection. For the time being, I'll just remove the components. So we have used 3 diodes in this circuit, a couple of resistors. I'll tell you the values of the resistors as well. So these are the couple of resistors. Then we need a couple of capacitors as well. One is a box type capacitor, because I should have used a ceramic capacitor, but because of unavailability of this component, I used a box type capacitor. Even the ceramic capacitor will work fine. And this is a main component, that is the 555 timer IC. I leave it as such. And this is our potentiometer. We can use a 100K potentiometer or 50K potentiometer, whatever you have. So this is basically our LED dimmer circuit, and we'll be using the 555 timer IC, which is the heart of the system, as in A stable mode, which gives us square waves. So the main important thing about this circuit is that we are not reducing the efficiency of the circuit by wasting the energy in resistance or as a heat. But what we are doing is we are using PWM signal. We are using pulse width modulation technique, which is also known as pulse duration modulation, and it is a method of controlling the average power delivery by pulsating the DC current. So if we see that in PWM, there are only 2 states. One is the positive state or the on state, and the other is the off stage or 0. So it is like a binary. We can consider it in a binary context. Now, the main important thing to know about PWM is the duty cycle or the power cycle. And from Wikipedia, it says that it is a fraction of one period in which a single system is active. Duty cycle is commonly expressed as a percentage or as a ratio. So duty cycle is basically the pulse width modulation upon time or upon time period. So if our duty cycle is suppose 100%, then our circuit is provided with current for the whole period of time. If it's 50%, it's just half. So for the half period of time, as you can see in the uh, GIF shown below, that the 10% duty cycle depicts that of out of 100, like in 1 second, only 10% of the or 10 millisecond of the time will be provided with energy, and rest of the time it will remain in the zero state. So that's basically what we are using in this circuit. Now coming next, so this is basically a circuit. The center of the circuit is a 555 timer, which is a 8-pin IC, and the like first is ground, second basically is the trigger pin, which we are using for triggering the circuit. So our main pin is right now the seventh pin, that is discharge pin, the second pin, that is trigger pin, and VCC pin. So in the left hand, in the right hand of the side, in the potentiometer, that is the controlling circuit, and I'll just write the formula for it. I hope you can see my paper. So we are basically controlling the charge cycle and discharge cycle of our capacitor C2, by which we'll be controlling the pulse width modulation or the duty cycle. So the charge time is given by time is given by it's also T on 0.693 into R1 plus R2 into C. Now, what is R1 and R2? So, in the potentiometer or in the right hand side of the circuit, the second part in the right hand side of the circuit, this R potentiometer underscore US, there we are using two fast switching diodes in anti-parallel configuration, and we are controlling the capacitance. So it works in two states, the charging state and in discharging state. So we are controlling the time of the charging and discharging state, by which we are controlling the speed of we are controlling the PWM signal, and that's how we are changing the output of our output or intensity of a LED. So now we'll try to make the circuit. So this was the charging time, and now the discharge time is basically, so it's also denoted as T off, and it is 0.693, again the same, into R3 into C. This is constant. So now we can design a circuit in such a way that uh, we can control the PWM signal as per our needs by changing the values of R1, R2, R3, and C. Now coming back to the circuit, now I'll just show you how we can design the circuit or how we'll make the circuit. So now we'll be making the circuit. So as you can see, this is our 555 timer. I'll just zoom in, and there's a niche or a semicircle, so that denotes that it's the top part or the front part of this IC. So our left side is 1, so the pins are numbered as 1, 2, 3, 4, and on the right side the pins are 5, 6, 7, 8. So as shown in the circuit diagram, we'll connect the pin 1 with ground. I keep connecting it. So we are using the upper part as a ground terminal, the blue one, and the lower part as a positive terminal. So I'll connect the first pin with the ground. Now our second pin is connected to the pin number 6. Second pin is basically a trigger pin, and we are connecting it also with a 1 NF capacitor. So I did not get a 1 NF capacitor in ceramic, so I'm using a box type capacitor. So 1 NF capacitor is connected to pin number 2, 6, and it's connecting it to the ground. So I'll first connect pin number 2 and pin number 6 with each other. So I'll use this only, pin number 2 with pin number 6, and I'll connect these two with the ground using a 1 NF capacitor. So this capacitor is also used for, okay, for maintaining the stability. It is basically to provide a filter out. Now this is now our pin number 3 is the output pin. So if we are not using a powerful, if we don't need a higher output, like if we don't need to run a motor or a string of LED, if we just need to run a couple of LEDs, we can use the pin number 3 directly, and we don't have to use a N channel MOSFET or any other switch for this thing, because it is about our 555 IC is capable of providing up to 200 milliamp of 200 milliamp of current. So but since we are using a higher load, so we'll be using a N channel MOSFET, and we'll connect it with our 555 IC. So we are using the third pin or PWM of the PWM signal from our third pin to the MOSFET and driving it. Now I'll connect the MOSFET later, or I'll just connect the MOSFET. So this is our MOSFET IRF-Z44N, and in this MOSFET, the first left side is gate. So we'll have to connect the gate with the third pin, because that's what we want to write. So this is a third pin, and we are connecting the gate with a third pin. Now just we change it because we'll need it. Now fourth and eighth are connected to our positive terminal. Now we have to understand that 8 is VCC, pin number 8 is VCC, whereas fourth is reset pin. We don't need to use the fourth pin here, but we can, if we wanted to switch off the circuit without removing the battery, we can use a toggle switch, or we can use a switch in between fourth and VCC, or in between fourth and power output, and by just clicking the switch we can disconnect the circuit. So now I'll just connect the pin number 4 with pin number 8. Pin number 4 is connected with pin number 8, and both the pins are connected to VCC. So I use the same. I connect pin number 4 and 8 with the VCC. I'm using pretty big wire. Oh, my circuit is visible. Right. Now, a pin 5, we just need it for filtering. So we are using the pin 5 just for filtration and making the system more stable. So we can use like whatever, a 100 nanofarad capacitor works fine for this. So we'll have to connect the ground with pin 5. So make sure that the negative terminal or the smaller terminal is connected to the ground, whereas the longer terminal is connected to your 555 IC's fifth pin. So we've done that. Now we already connected pin 2 and pin 6 with each other, and now we need to connect pin number 6. Sorry. So we need to connect pin number 6 with ground using, okay, we have already connected pin number 2, 6, and pin number 6 with the ground using a 1 NF capacitor. This is making a charging or discharging circuit, and this is a very important component for us, the 1 NF capacitor, because it is determining our charging time. Now the pin 7 is discharge pin, so I'll explain you how it works later. So pin number 7, as you can see, is connected to the positive rail through a 1 kilo ohm resistor. So this is a 1 kilo ohm resistor which I'm using to connect pin number 7 with. This is pin number 7. I'll connect it with the positive rail. Sorry, I made a mistake, I guess. Pin number 7 with a positive drain. And we need to connect two diodes in anti-parallel combination. I'll explain you why we are connecting it in anti-parallel combination just later. So pin number 7 with two diodes in anti-parallel combination. By anti-parallel combination, we mean that one diode is connected to the positive terminal and the other is in just reverse orientation, so that we can control the flow of current. And we'll be connecting it with our two pins of potentiometers, so as to make a, so we have connected it with a potentiometer, and to control the potentiometer, we'll connect pin number 2 and 6 with it. So the output of potentiometer is connected to pin number 6 with pin number 6, and we are connecting to pin number 2 and 6. Basically, we need to connect this whole segment, the potentiometer's output, to our capacitor for maintaining the charge or discharge time. So this is basically we have connected till pin number 7, and pin 8 was already connected. So basically our circuit is complete. Now what else we require? I think we missed a 200 ohm resistance that was used for connecting the we basically connected this thing with a wire, but we should have used a resistor to control the current. That is the gate with the third pin where we are controlling the output. Now we also need to connect our MOSFET with with a reverse diode or with a diode if you're using it for controlling a motor, because we don't want the reverse current to damage our MOSFET or damage our switch. So we'll connect our third MOSFET uh, along with the terminal of, like, the output terminal of drain, from drain to the positive terminal. To the positive terminal, I've connected it so that it doesn't affect, not to the positive terminal, to the, sorry, I just have to check it once again. So we have the drain of our MOSFET. We have the drain of a MOSFET and we are connecting it. Okay, we need to connect the negative terminal to the ground of the MOSFET. The drain of the MOSFET should be connected to the ground, and the positive terminal, actually that is not needed, but we can connect it if you want, to make sure that it doesn't affect the motor, but we can run it without that as well. Now I'll just power the circuit. We need to connect it along. So now I'll use our battery to power the circuit, which is providing 12 volt. And let's see the current now. Fully, what is visible? My voltmeter is visible in the screen. So currently we are providing around. Currently we are getting around 12 volt, and in the output we are getting 12 volt again. Now if we change the intensity, just we can change the intensity by rotating this knob. So when we change the intensity, so this should be like this. So the positive terminal is fine. Just sensitivity like this. Right. So now it's 20.45 volt. positive is there, negative is there. Okay, this is positive, this is negative. The voltage is still the same. I think I made some connection error, so let me recheck. So our pin 1 is connected to the ground as discussed earlier. Pin 2 is connected to pin 6, and both are connected to ground using a capacitor. Pin 3 is connected to our MOSFET using a 200 ohm resistor, and we are providing it to the gate of the MOSFET. Now pin 4 is connected to pin 8, and both are connected to VCC. Pin 5 is connected to the ground again using a capacitor, a 100 nanofarad capacitor. Pin 6 is connected to pin 2. We have discussed that earlier. Pin 7 is connected to the output of. Okay, sorry, I made this mistake. So pin 7 should be connected to this is pin 3, right? Pin 7 should be connected to our anti-parallel diode, and which should be powered using a 1 kilo ohm resistor. And the output is fed to. Okay, this is something I did wrong. This should be going, the output of this should be going to pin 2 and 6. Okay, so this should have been connected to pin 2 and 6. That's where I made the mistake. 2 and 6. It should be connected here. And pin 7 is connected fine. Pin 8 is connected fine. So now it should work, I guess. So our input is fine. Let's see what our output is. So I'll connect the drain of a MOSFET with our negative terminal and the resistance with the positive terminal. So as you can see in the potentiometer, that the potentiometer is connected directly to pin 7 using a resistor, and like it is connected to our power channel or the 12V channel using a resistor of 1 kilo ohm, which is reducing the current. Now when the potentiometer, as I've already told, that we can change the duty cycle by changing the potentiometer. So in the circuit, as you can see, the red line is showing how the current is flowing. So in the when capacitor is charging, in that case, the current is flowing through our R2 and then flowing through our Q1, that is the first diode, and charging the capacitor. So till the time it's charging, till the time it's not fully charged, it keeps on charging, and as soon as it charges, the capacitor starts discharging and the current starts flowing backward from capacitor. Next slide please, to the D3, and from D3 it goes to the discharge pin, that is pin number 7, which gives the input. When pin number 7 gets the input, it signals pin number 3 to provide the output to our MOSFET, thus turning it on. And as soon as that provides a small amount of signal to our MOSFET's gate, the negative current starts flowing from the drain is connected to source, and our circuit gets complete, and that's how our our light or any other device starts getting connection. So that's how this circuit is working, and basically this is what the circuit is doing. So that's all about the circuit. I've actually shown you the working of the circuit in the beginning, and basically that is all about the circuit. So if you have any questions right now, can you please, the floor is open for the question. If you have any questions, please ask the questions. Okay, so I think there's a question: how to make IR sensor that can work in sunlight using 555 time. Okay, Chetan, so this question is for another project. Right now we are just uh, for this project we are just using like PWM thing. So I can explain this thing later. You can ask this question uh, in that respective in some other portal in a forum. Okay, so the question is, can I use IRF Z44 in place of IRF S4229? So actually I've used the IRF Z44 in this project, but yes, you can use IRF S4229 or any other similar MOSFETs because those are also N-channel MOSFET and it will work. There won't be any problem. What's the question? Okay, so the question is, can we interface the triac with this circuit? Okay, you can post this question on the forum and we'll answer it there. Okay,